Well, welcome everybody. I'm Martin Baker. I help organize the Drop Talks here at Dropbox, and I want to welcome everybody. This is one of our biggest so far, so good to see all of you. And I keep forgetting to do this, so I need to blatantly pimp the company, which is that part of the reason we do this is so you know how great it is and you give us your resumes and you come work for Dropbox. So please feel free to talk to me or any of the other Dropboxers if you're interested in coming to work at this fabulous company. So I apologize. I know there were some people who couldn't come in. We limited it. We will be moving to a new space, and that will have greater capacity. So I'm looking forward to being able to have more people able to view these talks in the future. So anyway, our speaker this month is Hilary Mason. And she is Chief Scientist at Bitly, which I think is probably the best title you could ever possibly have. I'm really envious. I think Bitly has some things in common with Dropbox. So, there's like what's perceived as a small task done really well. And people think like, okay, well, you're done. Like, you built it. Great. As Hilary is about to explain to us, there's a lot more to it than that. So without further ado, please give it up for Hilary Mason.
Great. So can everyone hear me okay? Awesome. All right, so I'm Hilary. I'm planning to speak for about 45 minutes and hopefully show you some live demos of stuff we're currently working on at Bitly, which may fail miserably, but that's how things go. And then at the end, have time for questions. So you can ask them while we go or keep them to the end. And if you're shy, you can tweet them at me. I'm H. Mason. And if you're really shy, you can email them. I'm h@bit.ly. So I'm the chief scientist at Bitly, and people always ask me what that actually means. So I thought I'd start with that. So I'm not the CEO or I'm not the CTO. That means I have no real responsibilities. It's my job to take Bitly's data and figure out what's cool and interesting and what products we can build on it and to make it useful to people. I've been there over 2 years, and I've been working on the same data set, which is really a privilege because usually you have a problem and you find the data to solve that problem, but I'm in the position where I have the data and I can imagine all different kinds of problems and applications for it, many of which I'm going to show you. So I'm assuming everyone here is familiar with Bitly. If anyone isn't, this is the slide I like to use to explain it. So we take big, fat things and make them tiny. That is big, fat URLs and make them short like this. A little bit of Bitly trivia. This actually used to be a hash of the URL. It was initially a Jenkins hash function, but we had way too many collisions. So now it's something else, not actually a hash of the URL. And then when people click through the short URL, we issue an HTTP 301 redirect and send them to the long URL, and we collect a bunch of statistics along the way. And these URLs show up in places like this, or like this, really wherever people are sharing links with each other. So at this point, we've built this piece of infrastructure that is being used to share links wherever people are communicating. And it's really interesting. It's completely worldwide. So this is a plot. This is a Google WebGL open source visualization where I just plugged in Bitly data. So thank you, Google. But there's no map on this globe. This is just a sphere with Bitly clicks plotted by latitude and longitude, right? And you can very clearly see the United States. You can see Europe. You can see South America, Mexico. Africa is a little more touchy, but it's a worldwide phenomena. We get a lot of international traffic as well as US traffic. So most people still think of Bitly as a Twitter URL shortener, and it's certainly become a lot more than that. But nobody woke up one day and said, I know, I'm going to found a company that makes short URLs. It just sort of happened. And, Bitly was actually a feature of an entirely different product that failed miserably, but it became its own company. It spun out of BetaWorks, and it just started growing. And so for the first year, it was really about scaling and keeping up with the scale and growing the platform and integrating it in all different places. And then we sort of entered the stage we're in now, which I like to call the awkward adolescence, which is we have a piece of infrastructure that's interesting. We have an interesting data set. Now we need to know what to figure out what we're going to do with it. And so the problems I'm going to talk to you about tonight really all sort of fit in this exploration of what we can learn from the data. And the beauty of being invited to speak without an actual required agenda or a we would like you to speak about X is that I can talk about anything I'd like. And so tonight I'm really going to talk a little bit about history. We're almost done with that, so if it's boring, it's okay. A little bit about philosophy, mostly philosophy of analyzing data that is timely, in a timely fashion. A little bit of engineering, and maybe throw in a couple of cool tricks. Also Batman. So surprise, it's Bitly's 3 years old. We're talking about on the order of tens of billions of URLs. I actually asked one of our infrastructure guys this morning what the actual number was, and he told me MySQL doesn't like count at this scale, so we don't know. But we have an idea. And we're also moving off of MySQL for that piece of the infrastructure. Finally, it's been a long time. So the next question, because this is San Francisco, and when you're working on a startup in San Francisco, the thing you have to ask is, how do I change the world? By the way, I'm from New York, where we ask, how do you make money? Which is something we failed at. But the question we're really trying to ask is not how do we change the world, but can we understand the world? So can we use the data asset we have to sort of understand what's happening? And from that, we'll figure out what to do next. So we work in an area that is nominally called big data. I really hate this phrase. It's just data. I dislike the phrase because I spend most of my time and energy figuring out ways to take the big data and make it small enough to do something interesting with it. Or to take pieces of the data at the right time and to analyze them in a useful way. But in order to impress you with numbers, because I hear that's what we do, we're talking about on the order of tens of millions of URLs per day, generally somewhere around 80 million, hundreds of millions of click events per day, over 100 million actual human beings, generally around 300 million events. We do a lot of work to try and filter out which ones are people and which ones are not. And again, tens of billions of URLs, and we like billions of things. So I'm going to show you what the data looks like. It's actually really simple. We call a URL shortening event an encode, and this is what the record looks like. So we have the user's copy of the link, the general copy of the link. We know where it came from, we know what the URL is, and a timestamp. And then a decode is a click, where we see a little bit more. Some of this is user agent, location, time zone, again, IP, the username of the person who created the link, the host header they clicked through. So we actually power around 20,000 different short domains. That's our main business at the moment. Here it's a bit.ly link, who referred it, where the URL was, timestamp, latitude, longitude. So very simple data. We fetch each link and do a lot of analysis. So we actually pull the content, analyze all the redirectors, analyze that for spam and malware. That's one system. We do content extraction. So we pull the meaningful text out of the document and store that. And then we do a bunch of things, which I'll talk about later, but we look at distributions of refers, the geography, the language. We look at which phrases are statistically significant in that page. And then we apply some labels to that page, like is it a sports article? So before I get into the fun techie stuff, nominally I run a team that does what people call data science, right? I think of data science as having two main components, the first being analytics, and the second being actual science. And many companies break these into separate teams. So a lot of companies have an analytics team, and then a team that does machine learning. We do it all in one team, sort of on the philosophy that if you can do fancy math, you can also do simple math. Analytics is when you can count something. Like the math you need is well understood. The hard part of analytics is asking the right question. On the science side, the hard part is often doing the math. The question might be trivial, or it might be hard. So we do both. Right. Things you can just count versus things you can't. It turns out you can actually get really far with just counting things. I'll show you some examples of that in a minute. And so people who are data scientists tend to share these attributes. So they have some mix of math. We have 2 physicists, 1 applied mathematician, 2 computer scientists. Engineering, that is the ability to actually build systems that let you do these things. Computer science and algorithms. And then what I call hacking, which is you just know a hacker when you see it, like someone who can actually get something done, right? So if you put all these things together, just wait, it gets better. Okay. So these are the kind of people I work with, and they are awesome. This is our team right now, and they're kind of embarrassed that I included this photo in the presentation. It's the only photo of all of us together, and it's at the Temple of Dendur in the Metropolitan Museum of Art in New York, which, if you've never been, it's an ancient Egyptian temple that's been transplanted into the edge of Central Park. And we went there on a field trip. It's actually a terrible picture of all of us. But the reason I wanted to put it up there is twofold. One, to show that there actually is a whole team with very diverse backgrounds working on these problems. And second, to say that when I say we do something, it is the academic royal we, which generally means they. And they're awesome, so they deserve a lot of credit. So what can we learn from people talking to each other? So when you start to look through the Bitly data set, you realize most of it is Kim Kardashian and kittens. And so what we've actually collected is gossip, right? So we have now a representative sample of all the world's gossip in one place. And we can really learn some cool stuff from this. The first thing you learn is that social networks are different depending on who you are, right? So this is a legit screenshot. Right? So this girl thinks any white person on Twitter is spam, and for her, it's true. For most of us in the room, not true. And then this one is a guy who had a Lego funeral for his goldfish. Like, this was really popular today. Right? This is a version of Facebook that I don't see. So we learned things in aggregate that we didn't know in general. I'm going to start by showing you things we learned from just counting. Right? So how do we use different devices? This is something we put on our blog last week, but we went and took all the data from 2011 and ran it through our Hadoop cluster. So we have a 10-node cluster. Each node has 8 cores. We fit all of our logs into HDFS, and it lets us do things like this pretty easily. So we took the user agent strings in that decode that I showed you and just mapped it down. So this is midnight Monday, and these are the days of the week going through Saturday and Sunday here at the end of the week. This is device usage over time. So desktop here means any computer browser. Yes? No, we normalize for time zone. So what you see is that desktop computers are used during the workday. Phones are smartphones. That's all of the smartphones lumped together, right? They're used throughout the day. Tablets are mostly iPads. They're used in the evenings. I had to buy a bunch of people beer because I bet against that. And then gaming devices are things like PS3s and Nintendo DSs, and they're actually used in the evening, particularly on Thursday. So, right, so I have a feeling that's college students, but that's just a theory, right? Thursday is computer game night. So there's something we can see here around a few different things. So maybe if you want the most attention on your content, you're going to post it Wednesday around 10 a.m. in your time zone, right? Or if you're doing something that's mobile related, you're going to push it a little bit later in the day. Plus, you see everybody's lunch break, which is funny. And then we can look at device similarity. So on this graph, white means two things are the same, and dark means they're very different. So what you can see here is iPhone is obviously the same as the iPhone, very much like Android usage, not so different from iPad, macOS, BlackBerry, very different from a Kindle. The Kindle, in fact, is different from everything. What I thought was weirdest on this graph is that this is Linux, and this is Windows. They're the same. So like, I don't know what's up with the nerds here. Mac OS is different. Maybe that's college students too. But this is something we learned. Oh, question. Yeah.
What's the metric? Is that me or is that?
No, for you. Yes.
Oh, what's the metric for how similar two things are?
So the metric, or the question was, what's the metric for similarity here? It's similarity in that time series I showed you. So similarity by usage and time. All right, so let's talk about something really serious, which is, no, I mean it, this is serious. So what happens in internet usage when you're in a country where society is not stable? And so we made some graphs of bit.ly clicks during the Arab Spring, going from January of last year through the beginning of the summer, right? And you can see a few interesting things here. So this is Egypt, where they cut off the internet, and then here's where it came back. Or actually, I think I zoom in here. Yes. So that's Egypt. Of course, this is where all the fun stuff happens.
Do you have these graphs like available for us to share?
I'm happy to share it with you, sure. This is Tunisia, and this is one of the most interesting ones because in Tunisia, they did not interfere with the communication infrastructure at all. So if we zoom in here, that's actually where the revolution happened. And so we see this almost linear increase in usage of social media platforms up until this point, and then it declines, and then it's slowly been increasing since then back to normal, or slightly higher, but consistent normal. Right? Now, I'm not a political scientist, and I'm not going to interpret this, but I think it's really interesting. And we're working with some political scientists to actually tell us, since we can also see the content of what people are viewing in different countries at different times, whether there's anything interesting there. All right, so to lighten the mood, like I said, when we apply category labels to our topic, we actually have a category called silly things on the internet, which is lolcats, fail blog, pictures of fish funerals, and whatnot. In 2011, 3% of all clicks went to pages about the top 100 celebrities. And hours of Hadoop computation. Okay, so those are things we can count. Oops.
So, out of curiosity, how did you compute this? The most clicked? Or?
It's most popular, and it's a function of most popular in most social networks. Yeah, and a couple pictures of Catwoman kept getting in there, so there's also a regular expression match for all variations of the word cat. I think we had 16 of them. But I'm happy to share the methodology. We also did, I didn't put it in this presentation, but we did another look at types of content and how quickly they spread, and we found that things that are always interesting include things like pictures of cats. They'll come back. The half-life is really long, whereas breaking news half-life is very short. So things we can count cleverly. This sort of is on the line between analytics and science. We're really interested in knowing what spoken language is in a page, because if we're going to show you a link, I want to make sure that you speak the language that is interesting, like in that page, right? And so we were abusing Google's Translate API for quite a while, but then they shut that off. And then we found a better solution. Actually, we beat Google's Translate API, so I'm going to show you that trick. We have this raw data, and this comes from the browser headers of people clicking on links. Right, so this is the request for language, and the top one's Spanish, and it's kind of messy. English US, if not English US, English, Portuguese, Brazil, Portuguese, if not that, English, if not that, whatever, English, Great Britain, etc. When you stare at this long enough, it does make sense. But we can build a distribution for any given link. So this is one in Spanish about Google+, and you'll see the most popular language, that's ES for people who can't see. Next is English. Next is Catalan, next is Russian, French, Portuguese, Italian, German and Japanese. This was a pretty high traffic link. But we're able to look at the entropy of this distribution and then make a judgment as to what language is actually relevant to the page. And since I heard I should have code, usually my rule is 1 equation and 1 kitten per talk, but here's some code. This is the code that actually does that calculation. It's a little bit of Python, NumPy, and half of it is comments. So it's really not very fancy at all. It turns out if you actually just take a vote and take the first value, you're almost always right anyway. But that's how we did it. And this lets us find things like this page, which Google Translate thinks is English because Foursquare.com is English as Japanese. So even though it only has a small amount of Japanese content, we can identify it as Japanese because the people looking at it speak Japanese. So that's kind of neat. And we can do the same thing for geographic relevance. So we see the location of every click, so we can tell you if a page is statistically interesting in San Francisco versus somewhere else. So I'm also really interested in context, and I think one of the most interesting aspects of the Bitly data is that we can show you not just your link in your analytics, but people who clicked on your link also clicked on what, right? So here's something we did at the topic level for Scientific American that was in their December issue. And the whole idea was, how do people read about science online? And what else are they reading? And we found there are a few funny things here, right? So physics and fashion are really close together. This was from a few days of data, and somebody actually went back through and dug through and found that there was a story about clothing made of milk that became very popular that might explain that, which was pretty cool. You'll note that statistics, which is down here at the bottom, and math are up here. So that's kind of a joke because statisticians and mathematicians don't get along. Computer science is right in the middle, right where we belong. And then you'll see chemistry is way up here. Religion is here, and we didn't put it in the magazine, but adult content was also like way off to the side. So chemists are not, they're not reading anything else.
Which side was adult content?
So we find that people, good question. People who read adult content really don't read much else. The funny thing is this is also true of religion. So here's a map. It's sort of hard to see, but we wanted to redraw and this is just sort of a raw Gephi rendering that is something we're using in development. It's not published and not for final presentation. But the idea is we wanted to take the top news sources in the United States and draw a map of how people actually read them and how they relate to each other. And we found a few funny things, which you totally can't see in the picture, but things like a small percentage of people who read the New York Times read Al Jazeera, a small percentage of people who read Fox News read Al Jazeera, nobody who reads the New York Times also reads Fox News, and vice versa, right? And so we have a fun little demo that I will try and see if it works, where we can draw these maps dynamically. There's one. You see this? Yeah. So Tumblr is always fun because people who read Tumblr are interesting. So I got a note this afternoon that they were rebuilding the database behind this, so it really might fail. So this is a real-time map, as in the last 10 to 15 minutes, people who have clicked on links that are tumblr.com links are also clicking on these other things. Wikimedia, heyguys.uk, Storify, TinyPic. So you can add something else. It goes down there.
Is this the union or the intersection?
So, well, yeah. This, by the way, is all done in d3.js, which is an awesome visualization toolkit. And my colleague, Mike Dewar, made a library called D3Py that makes it really easy to take a Python data structure and come out with something like this. It's on his GitHub page. And as long as you're not trying to zoom in and give a talk, it actually does work really well. But this is sort of a fun, real-time look at what this data looks like right now. Go back to the safe slides. Maybe? All right. So the last section, and by far the most interesting, is problems we really have to think about. So I talked about a few things we can learn just by counting things up and looking at the data, and a few cute kittens, and then some of the interesting stuff looking at there. But most of the time and energy, or intellectual energy, that we spend is really spent on these sorts of problems, which sort of draw from machine learning. So one question is, what's human? And we see a very common pattern with links that are shared socially by human beings on networks or through other social mediums like email, which I still believe is the biggest social network. This is from this morning. This is a good load test for our system, but the article is Pregnant Bikini Shot of the Day, Kourtney Kardashian Breaks Out Baby Bump. When I took the screenshot, it was, 55 minutes old, and it had gotten almost 200,000 clicks. So we always see this pattern where we see an initial burst and then a decay. And this is consistent across social networks. The exact type of the curve will change depending on the network. So Twitter is a little faster. We find the half-life there is 2.8 hours. Facebook is slightly slower, it's 3.1 hours. There are a few networks that are very different. So like email is much slower, but still the same shape. The only ones that are really different are StumbleUpon, which shapes that graph deliberately, and YouTube is slightly different. It's much slower. But we really want to be able to tell if a link fits the criteria for being shared by human beings dynamically and in an online process that is with a partial time series, which is a challenging mathematical problem. And most of the time, we're not looking at things that beautiful. We're looking at things like this. These are normal click distributions for links that are not that popular. And really quickly, this is FML in Spanish. This is an album, InsideCarly.com, iParty. It's the internet. But we want to be able to distinguish it from abnormal click distributions, which look more like this, where the first one is this. It's a bit.ly link to this image that was being used as a forum avatar. So somebody was, and we see this use case quite a lot actually, people are using bit.ly to track analytics on a website they don't control by wrapping their forum avatar image to know how many people had read their post. We actually had someone submit a resume where they used a bit.ly link for every project in their portfolio so they could go see if we had actually looked at it, which is very smart. The second one was spam. Like this is, nobody wants that. And the third one was actually malware that we had already blocked. So we're really interested in knowing whether this is organic or inorganic. And I thought it's a good problem to talk about because it sort of exemplifies the process we use to solve these kinds of problems. So we went to our Hadoop cluster, we took a lot of time series, and we looked at them and said, what do they look like? What is normal? When we had a good sense of normal, we went and hand-labeled a whole bunch of data, and then we built a supervised classifier over that time series. There's also an infrastructure component in that if we want to do this in an online way, we need a way to get the full time series of clicks to a link in an online way. And so we have a database we call JujuFly for interesting personality reasons that will give you the real-time time series of all clicks on a link. And depending on how much memory you give it, it'll give you that many clicks. And so eventually we had a supervised classifier. It pulls the real-time time series, and it's pretty good at telling you human or not human. Fine. But then we needed it to be fast, which means that we then would go through a process of taking that interesting math and saying, okay, these are the features that we need to understand what's happening, which means that our classification has to be interpretable, that is human understandable. And then we built, finally, a random forest ensemble classifier based on a decision tree that can do this really quickly. And now we're in the process of coding that up in C. So we train it offline, it learns. The random forest, it's an advantage in that as an ensemble classifier, we can assign different weights to it. If you really want to zoom in, it looks something like this. And eventually it'll tell us whether something is being shared organically or not. Yes?
What are the level features that you compute from a partial time series?
So the set of features we look at are things like the shape of the time series, but also really simple things like the countries sending clicks to a link. That's actually more significant, and the languages too. But we find that we get a lot of spam from certain countries. So we have a new fortune cookie rule at Bitly. You know the fortune cookie game where you add embed to something? Well, when you've solved a problem, we say, but have you solved it at scale? So that's our fortune cookie rule. And here's the process. So we're using this sort of process to build a few applications and product applications. Now I'm getting into the more fun stuff. So how many people here have worked on a search service before? That's quite a lot, actually. That's great. So I don't think that search is a solved problem. A lot of people have given up and said, Google has done it. I don't think so, and I think Google is actually getting worse for a couple of reasons. One being that they're so successful, they're targeted. So if you search for something like refrigerator reviews, you can see that it's all spam. And the second reason is that our expectations of what a search should provide have changed completely. We live in this social world of real-time data, and they're not there yet. But Bitly's trying to get there. So we built a real-time search engine. We have different kinds of attributes in this search engine. So some of them are calculated at index time. That is, we use things like TF-IDF for term relevance. That's term frequency inverse document frequency. It's old school. But some of the values are calculated at query time, and that is how many clicks something has gotten this second, the different social networks that have referred traffic to that thing. It's a pretty cool system. It's built on Lucene, Solar, and Zoe from LinkedIn. And then we use Redis, which is sharded into a cluster to do all the in-memory stuff. So I'm actually going to just show you what it looks like, because that's way more fun. This, again, is not a product. It's a debug interface into something that's intended to be an API. And we designed this UI the week that Google launched their URL shortener, so there's definitely a lot of ripping off that went in there. So this is a query for the word pizza. Everybody loves pizza, and this is one of my favorite demos. Also, query for coupon is a good one if you're into that stuff. So what this does is it essentially takes all of the Bitly documents that have been shared or read in the last 48 hours, takes the segment of data that contain the word pizza, and rank orders it by current trendingness on this function. And that's okay. But we can also do things like this. Which is a query for documents containing the word pizza being clicked statistically disproportionately from New York. Yeah, that's newyork.eater.com, New York City. Usually there's something in here about cheap pizza, because it's New York. But we can also do this. And usually there's something about brie cheese and pizza stones, because it's San Francisco. But that'll do. All right. The fun thing about thinking about search as a ranking problem, yeah.
What are the numbers after the link?
So the numbers are our current score for that document, and then the score taking into account time, weighting, and other decay functions. So this one had a lot more traffic probably, but is older. This is, again, it's a debug UI.
How close does Bitly's information correlate to kind of other data streams? So you're saying, hey, we're looking at stuff and it correlates with one of the prices, but what about if it kind of correlates to Google's data streams, Twitter's data streams?
Well, if Google and Twitter would give me their data streams, I would tell you.
Because you're
So I've looked at
learning a lot.
correlations. So yeah, I mean, all we're doing here is searching the subset of data we have. We do have access to DNS data, and so for at least the .com portion of the DNS space, I can tell you that we are correlated with the representative section of the internet. Outside of that, I don't really know. That, by the way, how many different .com domains do you think are actively queried in DNS in a day? Because I just found this number out, and it really surprised me. So we have a guess, 700 million? Anyone else? 1,000? A billion? So the answer is actually around 100 million per day. I thought the internet was bigger than that. So this is also a query where we say, give us every document being clicked statistically disproportionately in San Francisco and just rank order it. These are actually fairly intellectual, I'm glad. Yes, we have plans to make this a product.
Oh, okay.
It is currently part of our enterprise product, and we're rolling out a whole new consumer product in the next few months, and it'll be part of that as well. So I have one more demo. Okay. So what we're really interested in, and what I usually say our research goal is to understand what people are paying attention to on the internet in real time. And so we've built another system that does that. And so what we actually want to understand there is the actual rate of clicks on phrases versus the expected rate of clicks on phrases. And I've made some editorial decisions here in that I'm using the word phrases to represent things people pay attention to on the internet. We look at up to 5 grams. We use a positional keyword extraction algorithm. And I can go into details there. But we built a system we call DragonEye. So DragonEye, it's the goldfish with the huge eyeballs that lives in your Chinese restaurant. We're very fish-focused at Bitly. So we want to calculate click rate at a moving average. And there's a lot of really interesting math that lets you do this. Time series really are special data. But we figured out a way to do it as a sum, which is awesome because it lets us do it very quickly. So we have a continuous function of time that simplifies. It's linear, which means the sum of the click rates is understandable, and it's fast. And it's important that this is understandable because we want to put this data in front of human beings and have them be able to say, okay, this is getting 30 clicks per second. That makes sense to me, right? And then we also use a distribution here that forces the result down to 0 at the origin, so we don't respond to trends that are, a tiny bit over 0. We want to see things when it's a significant leap. And I'll just show this to you, if it works. So the things that are currently most bursty are, no surprise there. Actually, I have this theory that Kim Kardashian has a little room full of data geniuses where they've figured out like when to suppress stories, when to promote them. So let's look at Carnegie Hall. So these are the stories that are contributing to that particular phrase, Carnegie Hall, trending, bursting right now. And we can go look at the info page for this. Oh, it's a shame this doesn't all fit on the graph. So this is the time series graph for the phrase Carnegie Hall through all of Bitly. That is every web page containing that phrase over time. And then we can also go see, there's that story and its contribution to the total time series. This story. So Jay-Z and Alicia Keys performed last night. Of course, let's see what's going on with Jennifer Aniston. She has a boyfriend. This job, by the way, is the best way to take a bunch of nerds who did not know anything about celebrity culture, and like we are all experts on who's got a puppy. All right, see, nobody cared about Jennifer Aniston until this story, where she opens up about her boyfriend and her never-ending Brangelina triangle. All right, that's more than enough of that. Come on. Okay, so a little bit of philosophy to sort of conclude. Simple math is always better than fancy math, especially in real time and especially at scale, and that's something I learned the hard way. This guy was pretty significant in our data last year, but a question you always need to ask when working on this kind of data is, how do you know when you've won? So if we're building something that tells us what people are paying attention to, like how do we know when we've done it right? And sometimes it's really easy. Like sometimes you're just counting something and you can figure it out pretty simply, but sometimes it's hard. And so, sometimes you're building a search engine. You want to know if your ranking function is ideal. And so you have to be pretty creative about figuring out when you know you've done the right thing or when you're done. And then how do you communicate this effectively? And this was actually something I learned the hard way, in that I didn't really take an interest in data visualization until about a year ago, when I realized I'd built all this cool stuff and nobody really knew what to do with it until it could be visualized. And so until we had pretty graphs coming out the other side, it was just a really nice, I'm very happy with tables of numbers, but most people aren't. And fortunately, we live in a time when there are great toolkits for making really pretty graphs quickly. I'm a huge fan of IPython with the integrated matplotlib. If you haven't seen it, it's really badass. All right. And the last thing is just ask crazy questions. I really want to know how big the internet is, and I'm going to figure that out in the next couple of weeks from the data we have. At least, with more confidence than I've had in any other number I've seen. If anyone here works at Google and you just want to tell us, that would be fine. But I'm going to make a guess. And I usually find that the crazier the question you can ask, as long as you can formulate it well, the more fun the result is, and then the more useful that becomes later on. And so with that, thank you. We have plenty of time for questions.
Bitly's not obviously the only way to share links on the web. So do you think there's a bias in all of Bitly in terms of who's using it and when it's shared?
What do you mean Bitly is not the only way? I'll repeat that. So the question was, is there a bias in the data set, basically? And the question is yes, or the answer is yes. Of course, there is a bias in the data set. That's pretty much okay with me. I'm not using phrases like understand what the internet is paying attention to in a scientific context. If I did, it would have error bars and confidence intervals with it. But I do believe that we have one of the best data sources for understanding that stuff. And we can quantify what the bias is based on that DNS data.
What do you mean best in terms of the most quantity, or the one that's most balanced across bias?
So I don't know which other, there may be other systems that see links being shared across different social networks and different online environments. I think Bitly is one of the most prolific platforms for that. We see a lot of data from networks that most of us have forgotten about, like LiveJournal. We see a ton of data from Tumblr, like data from Twitter, Facebook. And so we have that set that's fairly independent. We can see things jump from one network to another and from one person to another. And I think that is uniquely interesting. It is very biased.
A few slides back, you gave us this way that you sum up time series data more but kind of quickly. Would you mind going back and explain it in a bit more detail?
Sure. Yeah, I sort of sensed that people were getting restless, so it did not seem like the time to do a mathematical proof. But yeah, I'm happy to talk about that. So essentially, we went through this process of looking. So it actually took me a long time to come around to the opinion that time series is a special kind of data. And the same thing for geodata, in that you can make assumptions about it that make it much easier to work with. So we spent a while figuring out how to do what is essentially a continuous moving average of the time series. So we started out the way anyone would start out, by saying we have clicks at the second resolution. We're going to put them in buckets by minute. We're going to put them in buckets by hour. We're going to put it in buckets by day and look at it. But depending on the link, what happens is that you get like all your data in one bucket. Or if you're looking at it by minute, it might look okay, like that Kim Kardashian link or Khloe Kardashian link from this morning. That was by minute, and it was pretty understandable. But if you're looking at it by day, you can't learn anything, and then you've got this problem with the discrete data where it isn't really useful, and then if you try and draw a function on the discrete data points, you're lost. And so we wanted to look at it in a continuous way, and so the math to do that is a few integrals. It's fairly intense, but we eventually figured out a way to do it as a summation. And it also has the added advantage of being something a human being can understand, which is really nice.
How is your data stored? Carly, what is the pipeline of data coming in, and then how is represented in your backends, and which technologies are you using?
Okay, so the question is, how do we store data? What does the pipelining process look like, and which technologies are we using? And everyone had better get another beer, because this is a really long answer. So the way Bitly is built basically as a services-oriented architecture. We use internal APIs for everything. The way the data is stored when I work on it is mainly in text files, which, I can't tell you how great text files are. Text files on HDFS, for a long time, most of my MapReduce was awk and grep and sed, and XRs. We do keep our core URL store still in sharded MySQL. We're using a homegrown time series database for our metrics called Clickatron, which is open source. If you go to Bitly's GitHub page, there's a lot of C code there under the simple HTTP project. That also includes a queuing system we use called SimpleQ. It's really simple. It's a queue written over lib event that has an HTTP interface. For most of our data systems, I'd separate them into the online and the offline. That is, we use Hadoop for computations that are research computations. We don't care how long it takes to run. We named our Hadoop cluster Vin Diesel. We make a lot of jokes about that. For things that run online, we're mostly using Redis at the moment. We also have another homegrown database that we're using for that bursting and trending phrases system that's called MemoryFly, which, as a little fact, is the database that underlies Chartbeat, one of our sister companies, which is all written in C. We also back up all of the data to S3. And last time we checked, had more than 1% of S3 objects were owned by Bitly. I would like to see that, actually, because we create a record for every URL shortened. And we'll see. But, please.
Do you recommend any kind of intro book to, data science or machine learning that would give the reader kind of a good base of knowledge for talking about it?
Yeah, so the question is, what intro books would I recommend? There are a few. So there's a book coming out in a week or two by two New Yorkers, Drew Conway and John Miles White, called Machine Learning for Hackers, and it uses R on web data and email data, and it should be awesome. I've only read 3 chapters of it, but they were good. I also recommend, if you like Python, Toby Segerin's Mining Collective Intelligence, which is getting a little outdated. Sorry to Toby if he's around somewhere or watching this on the internet. But it is a really nice introduction to how to think about a machine learning problem with real algorithms and real code. Not things you'd run at scale, but things that sort of get you thinking. And then if you already have the engineering side and you just want the math side, Bishop's Pattern Recognition and Machine Learning is the core canonical math book to look at. it does assume that you know something about statistics.
In your analytics, how do you distinguish between like crawler/bot clicks and human clicks?
So how do we distinguish between crawlers and humans in analytics? That is both an art and a science. So there are really three ways. The first way is we have a list of non-human user agents that we sort of add things to over time, which I think everybody does. The second thing is that we consider all traffic that comes from the Amazon EC2 IP ranges to be non-human. Those 3 people with their proxy servers don't count, right? And then the third way is that we actually do some traffic modeling on known non-human traffic to look for patterns that are clearly not human, and then try and apply that to the rest of the traffic. I have to say that's been a project with mixed success. Generally, it turns out that it's easy enough to spot things that are not human when you look for them. Of course, I don't know how much of it we're missing, but I think we're doing a pretty good job.
You talked about meaningful phrases for a while. How do you feel about determining what a meaningful phrase is?
That's a very good question. So how do we know what is a meaningful phrase in a document? So most of the content we see are web pages, news articles, blog posts. So we'll pull the content. We have a content extractor, which will actually, along the lines of readability, pull the meaningful text. And that runs on a couple of classifiers and some heuristics. Once we have that text, we also know which content in that text was in a title tag and an H1 tag and an H3 tag. And so we have what is technically a positional keyword extraction algorithm, but basically we look for phrases that occur statistically disproportionately and in one of those significant fields and in the body of the document. And that's fast. And so there are ways to solve that problem more ideally, but they're all much more computationally intensive, and this is good enough.
So positional keyword extraction? Is that
Yes. It means you look for phrases in the most important parts of the document and then verify that they're actually important and interesting by normalizing, and then that's it.
Have you ever thought or ever tried to create a key so you can kind of hook up to somebody's specific actions and then kind of infer future actions? I know it's kind of privacy kind of meddling, but
Yeah, so we do have, my colleague Brian has a project he's been working on for a while called Front Runners, where we look for people who click on links that go on to become popular in a predictive way. So we're not going to call it influencers. Like, they might be someone like Tim O'Reilly who reads something and then tweets it and then it gets a lot of traffic, or they just might be someone who reads the right newsletter early in the morning and clicks on links. But that's actually, I think that's a very interesting area to pursue. We're also looking more into, given the set of things that you've clicked on through Bitly, what can we do to predict your interest in content? So as part of our consumer app, we want to be able to say, of this 1,000 links we might show you, which one will you be most interested in? I don't think that actually gets into any privacy issues, unless we were making that data public.
we're selling it.
Yeah, which we're not. Oh, sorry.
As kind of a follow-up to that, or do you, on the flip side, look at people who are creating links that do become like highly popular, and see, do you look at their behavior as because they are much more likely to be trendsetters, followers, if they're seeing this data early and then setting it out to the rest of the world?
Yes, and we look at people who will click on links and then go on to reshare them.
I think that my question is really similar. Whether you're interested in, more generally, whether it's because of the person being an influencer or whatever, which things are going to be popular, and knowing that before they're actually popular.
Yeah, any phrase like influencer that becomes very popular with marketers and not scientists sort of scares me a little bit. And I'm not confident in our ability to identify influencers. I think we can identify people that correlate with activity, but I won't go out and say that, yes, you will drive 100,000 clicks if you share this link.
I didn't mean to focus on the influencer piece. I
Oh,
just meant
okay.
A link, knowing that that's going to be a popular link before it is popular.
Yeah, so we have done some work on prediction in that since all of these links follow the same spike and decay model, once we've identified the point at which it started to decay, we can predict how many clicks it's going to get. with a pretty high confidence. The trick is figuring out when it started to decay, because when it's still on that spike, you don't really know. And then figuring out what to do with that. Okay.
I'm not sure if you mentioned this, but what are you migrating from SQL to?
We looked at React, but I'm actually not sure. I don't think any final decisions have been made.
My question was the product conversion, does Bitly expect the data science team to kind of come out with product ideas, or is that just like a kind of nice coincidence, or like I guess I'm more asking how do products become made at Bitly, or
Right, so sometimes by accident and sometimes by design. The question was, how do products get made at Bitly, right? So we have two products that are really important, right? We have our consumer site, bitly.com, and a bunch of JavaScript sidebars, and we have a Chrome extension. And that currently has a team dedicated to reimagining it. So in the next few months, the Bitly you see is not the Bitly you see today. And then we also have an enterprise product for which we charge people a lot of money, and so that also needs its own attention. Our role is more to contribute on both sides, and I see it as sort of laying down the path where the product can possibly go. So a lot of the things we build and some of the things I showed you may never show up in a product as they are here, but may show up in a completely different way. So an example is that for our consumer product, we're going to have real-time link recommendations, probably. That is based on click co-occurrence, so people who clicked on these links are also clicking on these other links. And then we're going to use that to get some good, well, it's going to be interesting. And that is, that's an application of several of the systems that I showed you here, but I didn't actually demo that usage. And that'll be, styled and worked into the product in a way that really makes sense. Yeah. I saw some hands in the back.
So you said you were currently writing a random forest implementation in C. How is it currently implemented?
We do all of our development in Python, and particularly on my team, we're in love with NumPy, SciPy, scikits.learn. And so we do, especially when we're just exploring a data problem, all of that code is in Python. And then if we have to, we'll write it in C. R does not like data that won't fit in memory. And R does not like to run in production. We do use it to make pretty graphs, though. There's another hand in the back.
What happened to Bitly.tv?
Okay, that's wow. What happened to Bitly.tv? So Bitly.tv was that was actually the first thing that launched publicly after I joined, and the goal of Bitly.tv was to prove that we could find something in the data that was interesting. So Bitly.tv took the segment of data that was videos and just was a web page that showed you all the current most trending videos, which this is in quotes because that calculation was really primitive. And it had no language or geo-filtering, so depending on what time of day you looked at it, it would be like all Japanese, or all Portuguese, or all English. So it was really a proof of concept. It worked. The systems we built since then do that 100,000 times better. But if you miss it, let's talk. Only 5 people ever looked at that site.
So if I generate a Bitly link, and then later on someone tries to generate a Bitly for the same link, you give the same code, right?
No. So if you're a logged-in user, so the question is whether you get the same Bitly link back if someone else has already shortened it. If you're logged in, no, you get your own version back, and that lets you track the statistics on your link and the global link. Then you will get the generic link back.
You can get from how many requests there are for a particular link, and do you use that?
Absolutely. How many people have shortened a link is a pretty interesting factor. Much more sparse than how many people have clicked on it.
So you had a section on how do we change the world. So what are some specific things that
So we built Bitly TV, which has one fan. And so the question is, how do we change the world? We're still working on that. Like Bitly has been around a long time for a small company, but we're still really figuring out what Bitly is when it grows up. I think the opportunity offered by Bitly is in really starting to understand social sharing and social data in a way that's platform independent and not tied in and locked into any given network. We have found the cutest picture of a cat on the internet. And I do think there are a lot of implications around some of the political stuff that I showed you that might be really seriously meaningful. But we haven't figured it out yet by far, which is why I think it's still fun.
Will Bitly becomes the Google greatest nightmare?
We've got 6 people working on this thing. I don't think they really have anything to worry about. Certainly because we're not going after their ad business.
Yes. I understand that you have a pretty huge data set, but have you ever needed anything like bootstrapping or cross-validation?
Yes. In fact, all of this stuff is cross-validated. That is trying to tell how accurate. That's how we know when we've won, right?
Move things across to make their cross-validation more, trustable.
So we generally train off a well-understood subset of the data. So when we're building a supervised classifier, we train off a well-understood subset of the data, and then we do all of our validation there, and then we put it into production on data that we're not really able to validate in real time. So far, this works pretty well.
Number of validation folds, and do you also have a standalone test that you when it comes time to actually deploying an improvement, is it just that the distribution of your cross validation is good, or do you also have some held out set that you're
It depends. Completely depends on the project and the system and what the goal is. So a few examples are our spam and malware system is based. It's not a sexy thing to talk about, but we scan every link shortened for its resemblance to known spam or malware. Known spam and malware is defined by anything in our database already flagged in the previous day. That data comes from a combination of sources, public sources. It comes from some of our partners at different social networks. It comes from users who report links. And it comes from some of our unsupervised algorithms that are sort of looking through the data stream for weird anomalies or things that we know to have been spammy in the past. And then it trains a classifier, and then that classifier will run on everything that day. And we will attempt to validate it, but it's hard to know. And I have to admit that often the practical concerns of building something that works are what's more important than doing it the right way scientifically. Anything else?
So you mentioned, I think, that you had the order of hundreds of millions of clicks per day, and that there's 100 million or so DNS lookups. So that means you have the order of 10 clicks or so per on average per domain. You're also showing us graphs that had tons of thousands of clicks. I wonder if you could comment on the distribution of how clicks are spread among sites and what that means for you to build a product site.
Yeah, it would be much more effective to show you a graph. So the question is, what does the distribution of clicks to sets of links look like? It would be much more effective to show you a graph that looks like this. In that there are very few links that get a large amount of traffic, and then a bunch in the middle, and then a very long tail. In fact, we see a lot of links shortened that never get any traffic.
What percent?
It's actually a really large percent. I don't know what it is offhand, but it's significant. Here?
Do you write your Python, do you write your Hadoop jobs in Python?
The question is, do we write our Hadoop jobs in Python? I do. One guy on my team writes in Java because he loves Java. Even his Python looks like Java. Yeah. I mostly work with Python streaming, and most people on my team do as well. I'm actually, to be entirely honest, and because we've gone over the hour mark, so I feel like I can ramble as much as I like now, I'm not a huge fan of Hadoop. Not really at all. Well, first, I'd not write it in Java. And, so Hadoop is a very heavyweight infrastructure with very little insight into what's happening. And so you sort of trust it to take your data and take your code and do some interesting things and give you back your results. And it does that very well, but you necessarily have a certain amount of overhead. It has a lot of really stupid things like, in fact, maybe someone here knows the answer. We essentially want to rsync into HDFS. Why is that hard? Like, I'm serious, because we're about to waste a bunch of time tomorrow trying to solve this problem. If anyone knows the answer to that, please tell me. Can you what?
You can like map HDFS with views and then rsync locally.
Yeah, but there are issues if a file already exists. So we can copy things. Well, I don't want to get into the things that are giving me headaches this afternoon, but there are a lot of things like that, and it's just a little bit too heavyweight for the kind of data analysis we want to do. So often, I mean, if you have something that's very easy to parallelize, it's actually not that hard to write something that, you have a bunch of data, you put it in a queue, you have a bunch of queue readers on different machines that process that data, and then it comes out the other side. You can write that yourself, and it's almost as hard as using Hadoop. I'll stop ranting there. Yes?
Does like the prevalence of like Tico and Goo.gl and all these other somewhat of a copycat, does it concern you, or does that just prove to you guys that you validate your concept?
I mean, it's both, right? So again, being completely honest, we're entering a world where you're on a social network and you click on a link and you go through 4 redirectors, all of which are gathering data before you actually get to the link, and it's annoying. And it's really not the internet that any of us want to live in, but it's the internet that we have. And so, yes, it validates that the data is interesting, but I really wish there was a better way. And I'm saying that as, the person causing most of the problem, I think.
What metrics do you focus on most to determine how successful you are?
As a business, as a person? Well, as a person, it's really, how many adventures I get to have and how many interesting people I get to meet. So today's a highlight. As a business, this is actually a non-trivial question, right? So there's always revenue, which is good. For us, that's not, we're really focused also on growing our consumer product and also returning more value to people than we get from them in the data. And that's hard to measure. And then we also have the problem of, if you're running a social network platform and you approach Bitly about doing some sort of partnership, how do we value that partnership? So if you're going to bring us a bunch of new data, how do we value that data? And that's actually a problem I was working on, in that, how do you even think about those questions? And it turns out there are answers. You can say, okay, how many new URLs are we going to see that are socially interesting and we'll find in other social networks? How many new people will be brought through Bitly because of that? What is the nature of the content we're going to see? Is it content that we can then reshare, or is it, content that is going to get us in trouble? And so we can ask questions like that. Way in the back.
Have you guys looked at the Storm as an alternative to Hadoop?
So I sat in Nathan Storm debut talk at Strange Loop, and it looks pretty impressive and awesome, but it's also in Java. And, to be entirely honest, with a small team, we haven't had the time to really do it and to really implement it and get it up and running. And the other side of it is that if we had a system like that, I'd really want it to be in Python. They do some really cool stuff with locality hashing that I'd like to explore at some point. Yeah. All right, so one more question, maybe?
There's one. How much do your metrics Like lag behind real time. I'm assuming that like you probably compute real time to be like X amount of seconds or X amount of minutes behind, just because of the nature of
No, it's real time, baby. No, it's down to the second. So we do have a latency of a couple of seconds for our analysis infrastructure. Unless something's gone wrong and that our queues are backing up for some reason, you'll click on a link and you'll see it within a second. Okay, one more quick question. We do not use Scheme, I'm sorry.
Oh, that's fine. We should make a web page about how Java is portable. And then say also why all Java technology is bad to use. So just anyway on that.
Okay, so proposal from the audience to make a website about why Java sucks. and we'll call that good. Thank you, everybody.
All right. Well, thank you all for coming, and thank you, Hilary Mason, for your talk. So yeah, feel free to hang out and have some beers and talk about why Java and XML and WML and WAP, if any of you remember it, all suck. All right. Thank you very much.